Hello student, we start chapter number 3, motion in a plane from syllabus of 11 standard Maharashtra board. Now let me start some basic term related to the motion. Now rest. So when we say that body is in rest, so you can see these are the example. If body is at rest, it means that it is not changing its position. So position does not change with respect to surrounding, then the body is at rest. If car is at one point, then we can say that car is at rest. So you know that the tree is not changing its position with respect to the surrounding, so it is at rest. Now after that, motion. When we say that body is in motion, so body is said to be in motion if its position changes with respect to surrounding with time, then it is said to be in motion. Now, motion and rest are relative terms. Now, motion we divide into three types. First one is one-dimensional motion. What is one-dimensional motion? If a body moves in a straight line, then its motion is called as one-dimensional motion in straight line. If only one coordinate change with time, if only one coordinate of the coordinate system change with time, then body is said to be in one dimension. Now, examples here. Example of one-dimensional motions are motion of freely falling body if there is no wind, motion of an aeroplane on runway. So these are straight line motions, so it is coming under the one-dimensional motion. Now two-dimensional motion. A body moves in a plane, then the motion is called as two-dimensional motion because two coordinates are required here. Two coordinates are changing with time. Example, motion of planet around sun is a two-dimensional motion. Motion of billiard ball on billiard table is two-dimensional motion. Motion of projectile. When we throw anything in air, the motion is two-dimensional motion. Three-dimensional motion. So if body moves in a space, then its motion is called as three-dimensional motion. If all the three coordinates are changing here with time, then only it is called a three-dimensional motion. Motion of gas molecule, motion of bird, motion of kite. These are the examples of three-dimensional motion. Now let me learn some basic concepts. Path. What is path? Line joining the successive positions of moving body is called as path. So you can see the length of actual path between initial and final position gives the distance traveled by the body. The distance is a scalar quantity. Now let's see here. If you see a diagram here or if you see a picture here, person is moving initially 5 kilometer, then turn in another direction and moves 2 kilometer. Distance travel is 7 kilometer. And this is the path. Now, when the person start at point A, reach to B and again come to at A. So distance between A and B point is 5 kilometer. So one way distance 5, again when it is coming back, again 5. So total distance travel is 10 kilometers. Now displacement. Now what is displacement? So basically displacement is the directed line segment joining initial and final position of moving body, and it is vector quantity. So let's see what exactly mean by the displacement. When person is moving with 5 kilometer in one direction, again changes the direction and moves 2 kilometer, then The displacement here, this is the initial position, and final, this is a final position. So final position. Then we have to join a line between initial and final, and that line is called as displacement. So that displacement we can obtain by geometrical method, and it is a 6.57 kilometer, and the direction is shown by this arrow. Now you can see another example. A person is moving in one direction with 5 kilometer and again come back to the same point 5 kilometer. Then how much is the displacement? Displacement is 0 because here initial position and final position both are same. Now what is speed? Now speed is the time rate of change of distance of particle is called speed. We can write speed is equal to distance traveled divided by time taken. Or we can write in a symbolic format, V is equal to S divided by T. Note speed is a scalar quantity. Speed is either positive or zero or cannot be negative. So it is never negative. Speed of running car is measured by speedometer. Speed is measured in centimeter per second, in CGS, and in meter per second in SI system. Kilometer per hour also a generally used unit in a practical life. You can see a speedometer shows a speed in kilometer per hour. Now, uniform speed. So what is uniform speed here? If a particle or body is said to be moving with uniform speed, it covers equal distances in equal time interval. Equal distance in equal time interval, then only it is called as uniform speed. See here. So equal distance in equal time interval, then only it is called as uniform speed. So variable speed. So variable speed, when body is said to be in variable speed, the particle or body is said to be moving with variable speed if it cover unequal distance in equal interval of time. Means first half hour distance is x, and in next half hour distance may be other than x, then it is called as variable speed. Now average speed. So what is average speed? When body moves with variable speed, the average speed of body is the ratio of total distance traveled by it to the total time taken. So average speed we can write total distance divided by total time. This formula gives us average speed. So if I represent distance by s, then I can write, if I consider 3 sessions in time t, distance is s1, in time t2 distance is s2, and in time t3 distance is s3, divided by time 1, time 2, and time 3. So this is the formula for average speed. So V average is equal to total displacement divided by total time. Now here you can remember some generally used cases for the MCQ. I am telling you here formulas. The first one is, if particle covers first half of the total distance with speed A and second half with speed B, then average speed is given by this formula. Total distance divided by total time. By that, we can obtain this formula in terms of speed A and speed B. So here speed A in the first half, and in second half the speed is B. So time is same. In the first time, means first half time the speed is A, and in second half time speed is B. Then average speed given by this formula. Remember this for the solving MCQs. Similar manner, another case. So if particle cover first 1/3 distance with speed A, second 1/3 with the speed B, and third 1/3 with speed C. So first 1/3 distance with speed A, 1/3 with speed B, and 1/3 with speed C. Then V average is given by this formula, 3ABC divided by AB plus BC plus CA. So here A, B, C are the speeds. Instantaneous speed. When body is moving with variable speed, the speed of body at any instant is called as instantaneous speed. So let's see the position time graph here. So position and time. So displacement versus time graph. So if this is a graph, it means that position is not changing, means object is stationary. Now second graph. So you can see here position changes with time, but here it's a linear graph. So line, straight line passing through origin. It means that the object is in uniform motion. So here see the third graph. You can see this is a position time graph like this. Then object is in non-uniform motion. Means speed is variable here. So here speed is constant and here speed is 0. So here it is constant and here V is variable. Now velocity. Now what is velocity? So velocity is time rate of change of displacement of particle is called as velocity. You can see a formula of velocity, displacement by time, or we can write s bar divided by t. B bar is equal. Velocity is a vector quantity. The direction of velocity is same as the direction of displacement. So velocity and displacement having a same direction. Velocity can be either positive, 0 or negative. You know that any vector can be positive, negative or 0. So velocity is a vector quantity, so it may be positive, negative or 0. So velocity can be changed in two ways: by changing speed of the body, or by keeping speed constant but by changing direction. So by changing magnitude or by changing direction. So velocity is a vector quantity. So vector changes when magnitude changes or direction changes. Magnitude of velocity is called as speed. Speed changes or direction changes, then also velocity changes. Velocity is measured in centimeter per second in CGS and meter per second in SI system, or generally use unit kilometer per hour. Now you remember here. So 1 meter per second is 18 by 5 kilometer per hour. Or you can remember in reverse, 1 kilometer per hour is equal to 5 by 18 meter per second. So this you require in solving the problems. Now after that, uniform velocity. So when we say that body is following uniform velocity, a particle or body is said to be moving with uniform velocity if it covers equal displacement in equal time interval. Now variable velocity. A particle or a body is said to be moving with variable velocity if its speed or its direction both changes with time. So either speed or direction changes with time, then only it is called as variable velocity. Average velocity. So when body moves with variable velocity, the average velocity of body is the ratio of total displacement covered by it to the total time. So you can see here, average velocity is net displacement divided by total time. Or we can write in symbolic format, V velocity bar is equal to displacement, total displacement divided by total time. So for a body moving with uniform acceleration, average velocity is u plus v divided by 2. So if uniform acceleration is there, then only we can write u plus v divided by 2. Sorry, divided by 2. So this is the average velocity. So average velocity is also defined as the change in position or displacement divided by time interval in which displacement occurs, or we can write like this way. So net displacement divided by this net time. So average velocity is equal to delta x by delta t. So no effort, here you note one thing, no effort or force is required to move a body with uniform velocity. Now here you remember some cases. If particle undergoes a displacement s1 along a straight line in time t and displacement s2 in time t in same direction, then average velocity is s1 plus s2 divided by t1 plus t2, similar to the average speed. If particle undergoes displacement s1 along straight line with velocity v1 and displacement s2 with velocity v2 in same direction, then average velocity we can write s1 plus s2 in a bracket into v1 v2 divided by s1 v2 plus s2 v1. So we are not going the proof for this one, but you remember these cases. If particle travel first half of the displacement along straight line with velocity v1 and next half of the displacement with velocity v2 in same direction, then average velocity is given by this 2v1 v2 divided by v1 plus v2. If particle travel, fourth one, if particle travel for time t1 with velocity v1 and time t2 with velocity v2 in same direction, then V average is equal to V1 T2 plus V2 T2 divided by T1 plus T2. So here we are considering same direction everywhere. So one more case, if particle travel first half time with velocity V1, next half time with velocity V2 in the same direction again, then the average velocity is V1 plus V2 divided by 2. Now let's see here position time graph. You can see here. So position versus time graph. Now here, slope of this type of graph gives average velocity. If you find out slope of this curve portion, we get average velocity. Now uniform velocity. So here, see here, position time graph for stationary object. So here, position time graph for an object with positive velocity. So with negative velocity, if negative velocity, then you can see this type of graph here. So basically negative velocity means velocity decreases. Now what is instantaneous velocity? A body is moving with variable velocity. The velocity of body at any instant is called as instantaneous velocity. Or we can write this instantaneous velocity like this by putting limit term here. So you can see this is a position time graph. The slope of this gives us average velocity that we learned in the previous one also. Now we talk about acceleration. When the motion is non-uniform, then acceleration term is very important. If it is a uniform motion, then acceleration is zero. But if it is non-uniform, then acceleration. What is acceleration? If velocity of body changes either in magnitude or direction both, then it is said to be have acceleration. So for freely falling body, the velocity changes in magnitude, hence it has an acceleration. For a body moving around a circular paths with uniform speed, velocity changes in direction, hence it has an acceleration. The acceleration of particle is defined as time rate of change of its velocity. You can see here acceleration. So, or we can write delta v by delta t is the acceleration. Similarly, we can write instantaneous acceleration by putting limit here. So acceleration at any instant is called as instantaneous acceleration. Now you note here, acceleration is a vector quantity. The direction of acceleration is same as direction of velocity of the body. Acceleration can be either positive, negative, or zero. Acceleration of body is zero when it moves with uniform velocity. Acceleration measured in centimeter per second in CGS and meter per second square in SI system. Kilometer per hour square also a unit used for the acceleration. Now you can see here some position time graph. If you get this type of graph, it means that acceleration is positive. So this type of graph, it is negative acceleration or retardation. So retardation means negative acceleration. And zero acceleration, here this is uniform motion. V is constant here. So this is a zero acceleration here. Now you can see here some velocity time graph. Now this is a graph one. So here motion in positive direction with positive acceleration. If you get this type of graph, positive acceleration. If this is a graph, means speed decreases, means negative acceleration. Or you can call this as a retardation. Retardation means negative acceleration. Now you can see this is the third graph. So motion in negative direction. This is negative direction. So here negative acceleration like this. And here motion with negative acceleration. You can see the fourth one also. Now let's see kinematical equation of uniformly accelerated motion. Now we consider a vehicle moving with initial velocity v u, then attain a final velocity v. A is the acceleration in time and the t is the time. Then first equation of motion we have to obtain. You know that acceleration is final velocity minus initial velocity divided by time. So acceleration we represent by a, final velocity by u, v, initial by u, and time is by t. Then by cross multiplication we can write v minus u is equal to at. So by that I can write here v is equal to u plus at, and this is the first equation of motion or first kinematical equation. Now here second kinematical equation you can see here. So this is a velocity time graph. Initial velocity is u, final velocity is v in time t. Now here area under this velocity time graph gives us a distance traveled by the car. So area under this is equal to, we can call it as the area of triangle plus area of this quadrilateral OACD. It gives us total area. And this, both the area, if we add, we get a distance traveled by car in time t. So this area of triangle is half base into the height. So we can write like this way also, half base is AD and height is BD. Or we can write AE also. This is for area of triangle. Plus area of this quadrilateral OACD is OA into this OC. Now you can see this AB. So this is equal to T. This BD is V minus U. So here you can see here 1 by 2. AD is T and this BD is V minus U. And this 1 by 2 as it is. OA, you can see here OA is what? 0, U minus 0 or U I can. And this is what? OC, this is T. So U into T. Then after that we get this one. Let me rearrange it. So we get it here ut plus 1 by 2. This I can write the same equation, S is equal, or we can write it like this. So ut plus 1 by 2. So this v minus u into this t. Or I can do one thing here, divide by t and multiplied by t. So we get t square and this v minus u divided by t is the acceleration. So we get acceleration at square. I hope you understood this. So u t as it is plus 1 by 2. So this v minus u divide by t, and this multiplied by t. So we get this one acceleration and this t square. So this is the second kinematical equation. Now similar manner, third kinematical equation also we can obtain. So we write average velocity. So average velocity is the displacement by time. So by displacement is equal to average velocity into time. Average velocity is v plus u by t, 2 average speed. So s is equal to, we get this. Now in that we have to substitute here. A is equal to acceleration, change in velocity by time. So by that I can write t is equal to this, and this t we have to substitute instead of this. So we get s is equal to v plus u by 2 into this v minus u by a. So we get this one by simplification. Then I can use a formula of a square minus b square is equal to a minus b into a plus b. This formula we use here, and by that formula we get here the expansion of this term as a v square minus u square, and this 2a as it is. Now after that we can transfer this 2a to this side. So 2as divided by, sorry, is equal to v square minus u square. So by that we can write v square. So v square is equal to u square plus 2s, and this is third kinematical equation. Now we learn relative velocity. What is relative velocity? So velocity with respect to one another is the relative velocity. Now see here. So relative velocity of object A with respect to another object B is the rate at which object A changes position with respect to B. Now if I consider VA and VB be the velocities of object A and B respectively, then relative velocity of A with respect to B, we can write VA minus VB. Similarly, relative velocity of B with respect to A, we can write VB minus VA. So this is the relative velocity. So when we are talking about object A and object B, if they are moving with the same speed, then relative velocity in the same direction also, then relative velocity of object A with respect to B or B with respect to A is 0.